All right, so let's take a look at chemical bonding. All right, so atoms have energy levels in which the electrons move around the nucleus. All right, and so this is trying to show these energy levels, and the further they get away from the nucleus, the more energy those electrons possess. Okay, so let's move to this picture here. So the thing about these energy levels is these energy levels can only hold a certain number of electrons. And so that first energy level can only hold 2 electrons. So here's hydrogen, here's helium there, it can only hold 2 electrons. So when we get more than 2 electrons, well, it's got to go into a second energy level. All right? And so the second energy level and up, they can hold up to 8 electrons. So if we go over here, we see neon. It has atomic number of 10, 2 electrons in its first energy level, 8 in its second energy level. And so now it's full. So if we add 1 more electron in there, now we have to get a third energy level, which is what we see over here with sodium. Okay, now if you take a chemistry class, you're going to learn about these sublevels and so on. So this 8 isn't going to be hard and fast there. It's fine for what we're doing here. Okay, so as you can see, it's kind of this building process. So we have 1 electron in the first energy level, 2 electrons in that first energy level, you get a third, goes into the second, and then as we move along, we keep adding electrons in that second energy level until it fills up, then we start adding on to a third. All right. Now an atom is most stable or unreactive when it has a full outer energy level. All right. So what happens here is that atoms will either gain, lose, or share electrons in order to get that full outer energy level. All right. And by doing that, by gaining or losing or sharing, this is what's going to create the bonds between those atoms. All right. So the first one that we're going to look at is ionic bonding. And ionic bonding is a chemical bond formed by the transfer of an electron or electrons from one atom to another. Okay, so this is what we see here. Sodium has an atomic number of 11. So it has 2 electrons in its first energy level, 8 electrons in its second energy level, and then that last electron goes in its third energy level. Chlorine has an atomic number of 17. So it has 2 in its first, 8 in its second, so that's 10, and then 7 in its third energy level. So what sodium wants to do, it wants to have a full outer energy level. And there's 2 ways to do that. It could lose that 1 electron, or it could gain 7 electrons. And it's much easier to lose 1 than to gain 7. And chlorine also wants to have a full outer energy level. So it could gain 1, or it could lose 7. Much easier to gain 1 than lose 7. So what happens here is the sodium gets rid of that 1 electron, chlorine gladly accepts it, all right? And so now over here, sodium has a full outer energy level, and so does chlorine, all right? So by transferring that 1 electron from one atom to another, this makes the sodium positively charged because it has 11 protons and now only 10 electrons, 11 protons, 10 electrons. And chlorine now becomes negatively charged because it has 17 protons and now it has 18 electrons, okay? And so because they are opposite charges to each other, they are attracted to each other, all right? And this creates what are known as ionic compounds. And so this is just trying to show an ionic compound here. Ionic compounds, they have, some of these atoms are positive and some of them are negatively charged. All right, let's move on to covalent bonding. So that with ionic bonding, one atom gained, one atom lost electrons. So in covalent bonding, we're looking at sharing, all right? So this is a chemical bond formed by electrons being shared by atoms. So this is what we see with 2 hydrogen atoms. Each hydrogen atom has only 1 electron, but if they come close together, now both of those will share those 2 electrons. They both have a full outer energy level, and they're both happy. So with a single bond, they're going to share 2 electrons. So that's what we see here. This is trying to show it once again with hydrogen. This single dash line here indicates a single bond. All right. This is showing a double bond, which is what we see with oxygen. So they're going to share 4 electrons. And I don't have one of nitrogen, but nitrogen shows triple bonds, and so they're sharing 6 electrons. Okay. So what this does is it creates nonpolar molecules. So a nonpolar molecule, these are molecules that are neutral throughout. So there's no positive end, no negative end to these. All right? Now, in some cases, we can create what are known as a polar covalent bond. This is a chemical bond in which electrons are shared unequally. All right? And this is actually what we see with water. Okay? So when oxygen and hydrogen make these covalent bonds to each other, those electrons are a little closer to the oxygen atom than they are to the hydrogen atom. So they're not shared equally here. All right? So what this does is it makes that oxygen atom slightly negative. That's what that little delta sign means. Slightly negative. And it makes the hydrogen atom slightly positive. All right? And so this creates what is known as a polar molecule. So polar molecules, they have a positive end to them and they have a negative end. Okay? And so in some ways you can think of ionic molecules as being polar as well. All right? So when we talk about what like dissolves like, right? So water will dissolve other polar molecules like sugars, all right? And they'll also dissolve a lot of ionic molecules like salts. But the thing is, what they can't dissolve is they can't dissolve nonpolar molecules like oils, right? So that's where you get the oil and water don't mix, is because oils are nonpolar molecules and water is a polar molecule. What also polar covalent bonding can lead to is what is known as hydrogen bonding. And hydrogen bonding is not bonding within a molecule, but between molecules. So this is where a slightly positive hydrogen atom on one molecule is attracted to a slightly negative atom on another molecule. This is once again, we see this with water here. So here's our negatively charged, slightly negative charged oxygen atom here, and it's attracted to that slightly positive hydrogen atom on another water molecule. And so they show hydrogen bonds with these dotted lines here between the two. So this is going to hold those molecules together. Now this can also occur within a large, much larger molecule. So this is showing different sections out of proteins. And then when we talk about DNA, DNA is double-stranded molecule. So those two strands are held together by hydrogen bonds. Okay? All right, so let's take a look at chemical reactions. This is a change, a chemical reaction is a change in the chemical composition of matter. So a simple look at this is to say A plus B produces C plus D. So here the reactants are A and B. These are substances that participate in the chemical reaction, and then the products are C and D. These are substances that are the result of a chemical reaction. All right? So this is just showing a simple chemical reaction with taking hydrogen plus oxygen and making water here. So here, the hydrogen molecules and the oxygen molecules, these are the reactants, right? And the product there is water. Now, one of the things you might see here are these numbers in front. Those are called coefficients. These indicate the number of molecules of each compound. Because what you want to do is you want to start off with the same number of atoms of each element on the left side as you have on the right side. So that's, when balancing chemical equations, we're not really going to get into that in this class.